Hello again, people. Welcome once more to the my little part of the internet. Yes, following on from the previous video, what we're going to do today is show how I make the this little chip, make these two little LEDs flash. Very basic. This is just going to cover how you connect to the host computer so you can program the things. A little bit of basics on the programming, don't worry, it's not too scary. And then we'll finish off with how to connect some LEDs and we'll get them flashed. So, without further ado, this is Leopard Street. Yeah, so here we are at the desk. A few slight tweaks from last time. Same ESP32, screen so its protector removed. We have the rest of the wires have gone in, so we've got this is the 5-volt line. This bar along the bottom will be a 5-volt bar. This bar's slightly further up. Just checking that's actually pushed in. That one's 3.3 volt, 3.3 volt, 3.3 volt. Red is positive, black is ground. Ground is common across them all. Resistor and an LED. We'll come to those in a minute. So, what have we actually got here? Well, firstly, a little apology from last time. This thing is not an Arduino Nano, as I incorrectly mentioned. This is an Arduino Uno. So thanks to Henry Best 4057 for pointing that little mistake out. Sorry about that. Yeah, I get so used to using the Nanos, I sort of forget about the rest of it. So, on with the show. What have we actually got? I mean, where do you get these things from? So, have a little look. I tend to get them from AliExpress. And as you can see, if you type ESP32 into AliExpress, you get loads. There's lots of them here. There's some decidedly small ones. There's some that come with huge screens attached, which look quite fun. I've never tried those. There's the various other little sorts. You get all the other different modules and bits and pieces that come with them. Yeah, small ones with cameras. So that's just the sort of thing you can get from there. And these are the prices. I mean, as you see, these things are not expensive. Yes, that's plus VAT. Yes, there's a minimum order quantity. You can also get this stuff. These are sort of kits. So like this one here looks like it's got an Arduino Uno in it and a variety of sensors and other bits and pieces. That one's got some components in, so's that one. So this thing over here, and this is AliExpress. You can just get the component kits, which are things like, you get a collection of LEDs, resistors, capacitors, push buttons and things. If you don't really know what you're doing with one of these things and want to have a play, one of these all-in-one kits is pretty much a good idea. I don't like AliExpress. eBay's got them as well. For example, that's the little board I'm actually using. Although I didn't get it from here, I got it from where we're doing. Didn't realise you could get that one as well with a slightly larger, so 1.9 inch screen with high resolution. This little screen is, I think, 128 pixels by 64, so that's 170 by 320, so that's obviously quite a bit bigger. Comes down to what you want, really. So there's little ones there. And again, you can get the kits on eBay. And horses for courses, take your pick. So that's where we've got. Now, the thing itself, if we just go back to the thing itself, here is unpowered. So what I'm going to do is find the appropriate wire from in amongst all the other wires I've got on my desk, which you'll excuse. I'm just going to feed around, and this is the other way up, of course, because of course it is. So that goes in there. The board powers up. Blue light flashes a little bit, power light comes on, and the screen powers up. Wonderful. And that's where we were last time. What we're going to look at today is setting up how to actually use one of these things. Now, to do it, you need the Arduino IDE, and the way to do that, this is free to get hold of, is you go into Google, or whatever search engine you use, and you type Arduino, and you can click at home, which will bring you into their website. Obviously, you have to accept the cookie nonsense, because, yeah. And the one you want up here is Products, Arduino IDE. and whatever the most current version is. And there's the various install options on that one. That one, Windows 10 and newer, 64 bits. Just download. You can contribute on that. Things just download. You can skip past all of that, and that'll go away. That'll download, and I don't need to download it again because I've already got it. What you're then going to do is you're going to have to run that once it's downloaded, and it comes up looking something like this. Now, I've loaded in one of the example sketches in here. Out of the box, this thing does not support the ESP32. It's just one of those things, it doesn't support it. So you need to add it. Very simple. File, Preferences, and some text you need to add in down here. Now that's probably a little bit hard to read, but that's what it is. That's what you need to add in. I will put that in the description, so you don't need to bother trying to write that down. I'll put it in the description, and you can just literally copy and paste that into the IDE. You click OK. I've already done it, so I don't need to. That gets rid of that. You're now nearly ready. Not quite. You need to go into Tools, Boards, Board Manager, and in here, ESP32. And it comes up, and this is the one you want. ESP32 by Expressive System. The Arduino ESP32 boards are boards from Arduino themselves. I've not got any of those. And the other one you want while you're here, 8266. I think I briefly showed one of those last time. These are smaller boards. They're not as capable. They're a little bit cheaper. To be honest, their main advantage is they're smaller. So these days, if you care particularly about space, smaller. That works. And once you've done that, what you then do is you go to where it says File, and of course the menu. Oh, that's wonderful. The menus I'm showing don't show up on the screen. Brilliant. Yeah, I'll need to look at that for the next video. You go into Examples. There's one called Basics, and this is a sketch called Blink. And what this does is make the LED flash. So what I'm going to do now is try and hit Run. But before I can do that, got to go into the Tools menu, which also isn't showing. Yes, need to deal with that one. You have to select where it's connected. It comes up with a menu that says Port. This is the serial ports. On Windows, it'll be something COM. In this case, it's COM4. Which it says down the bottom corner when it's connected. It tells you what board you've got on COM4. Yeah, the way to do it is do this before you plug the board in and do it afterwards, and whatever else has sprung up is that. You need to select on the board ESP32 boards. This is where actually this not showing up is a little bit annoying. This one is an ESP32-Room-DA module. It put me off using the ESP32 for a long time when I saw the size of that list, and I thought, oh my god, how do I tell which one I've got? Well, if we just have a little look on here, read on the thing, that says ESP32 W Room 32, ESP W Room 32. Sometimes you will see on the listings, if we go into some of these here, some of these will tell you what it is. CP21, whatever. Sometimes they do, sometimes they don't. Yeah. It's annoying. The way to deal with it is you sort of have to experiment with it a little bit. But this is what we've got. So if I just bring this up, we can see the actual board. Sample of this, and what I'm going to do is I'm going to press this one here to upload it. Now this is going to go away and it's going to compile it. And it's then going to say, not going to work. This is another little problem here. See, LED built in. This is telling it which pin the LED is connected to. Now, it's actually on pin 2. I know it's on pin 2 because if I zoom in on the board, which is a little bit awkward to do with this camera, next to the LED it says GPIO2. So what we need to do is add a single line in here to tell it what that means. So we do that, 2. And what I'm saying there is, wherever you Mr. Computer, wherever you see LED built in, replace it with a number 2. And that tells it which pin we're looking at. So if I try again, it should go. Again, if you use an actual Arduino board, that works by default. For some reason, the ESP32 boards, it's not defined because they don't all have one of these. So here it is trying to connect. That's where we find out whether it will or whether it's got an error. Failed. Okay, right. So this also happens sometimes, so we'll try again. And I think I've got to press that one, which is a boot button. Excuse the finger. And what we have to do is wait for that to come and then release it. It's a weird one. Sometimes that works, sometimes it doesn't. And now we've got that little blue LED flashing. What I'm going to do, however, is unplug it back in. And the reason I'm doing that is because the screen remembered what it was told last time. So here, that's it. And that is essentially how this code works. So what are we actually doing here? Let's just reduce the size of this bit at the bottom. So I say this define command is just saying where you see that, replace it with a 1. Set up, this is a loop. Between these curly braces is, if I just put these down here where I think they should be, is a loop. Set up, it runs once when it starts up. And all this does is this little pin mode command. And it's saying the LED built-in pin, which remember we defined as a 2, which is helpfully telling us, is going to be an output. The pins on these things can be outputs or they can be inputs. If it's an input, obviously it is going to listen to input. Here it is an output, so we are telling the chip we want that pin to be an output. And we just do that once. And then we get into loop. And what happens is it runs through this loop, and then it does it again and again and again, and it'll keep doing that until it's told not to by switching it off. So the first thing it's going to do is say to this LED pin, put a high level of logic on it. So basically that pin 2, it's going to say, make that 3.3 volts output. Delay 1000, as the text on screen says, is wait a second. That's in milliseconds, so you can change that to be whatever you like. And then it's going to turn the LED off, making it logic 0. And if it's logic 0, it'll be connected to 0 at both sides, so it won't work. This will become a little bit more obvious in a minute when I plug the other LED in. And that's the example code. Yeah, what if you want to do something a little bit different? Well, what I'm going to do is copy all of that, paste it down here, and think, well, it's just going to loop twice. Yeah. So we're going to go... This is a little bit weird, the LED on board. It seems to be wired in backwards. So what I'm going to do there is go into that, and I'm going to say... So we're going to be off for a second, then we're going to come on for a quarter of a second, quarter of a second, quarter of a second. And what this should do is a little heartbeat, like da-da, da-da, da-da. So let's try. And again, I shall hold the boot button down in case it needs it. I say some of these boards need them, some of them don't. Go that. There we are. Yeah, the boot button tells it what mode it needs to be in. So now we have... Yeah, and what you see here is the fact this LED is actually wired backwards. High turns it off, low turns it on. You can wire these LEDs up in 2 ways. You can wire one between the pin and ground, or the pin and voltage. And if you wire it between the pin and ground, this is what you get. So this way, no, this is if you wire it between the pin and voltage, sorry. So when we say logic high, we're going to turn the LED off because it'll be 3 volts at one end and 3 volts at the other, so no current's going to flow. We go low, it'll flow. It's just a weirdity on these ESP boards. It is, however, extremely easy to fix. What we do is we go into our little code here and we just turn it round. And when you're using these things, this is just one of the little quirks you need to see. The Arduino is, for example, the exact other way round. Its light comes on when you press high and goes off otherwise. So we shall do this one here. There we are, uploads nice and quickly. These things have a decent amount of memory on them, but now they are. Ding, 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 ding. And we can change the timings on that. So let's make that 1/10 of a second. And with a bit of luck, you can see already that, I mean, making an LED flash is not particularly difficult. There's lots and lots of little electrical circuits that can make an LED flash. But here what we've got is a circuit that, without any real work, I mean, we've not really done anything with it, is making this LED flash in a way that would be a little bit harder to do. So what about this LED? What are we going to do with that? Well, if I go back to here, and we have a look at the next one. This is the chip we've got on the board. This is a photograph I took of it earlier. It's turned around so the labels are the right way up. And what we've got here labelled, we have the 5 volt and the ground pin, which go out. The 3.3 volt and the ground pin. You can power it on 3.3 volts. It's usually best not to. It's best to power it on 5. Unless you need a lot of 3.3 volt other things, in which case you're going to need the connector anyway. And here, as you can see, this is the little LED that is flashing. It says GPIO2 next to it. The red one is power, so you can see the thing switched on. Not all of these boards have a power light either, so some of them they switch on and you've got no way of knowing. So GPIO2 is this pin here, which is D2. So what I'm going to do now is connect up a little circuit. And what we're going to do is this. So I'm going to say, pin 2, I'm going to put a resistor, and I'm going to put an LED. Now this is something you need to think about a little bit with these boards. This resistor value matters. I know in model railway terms we're great fans of, if we're using, say, a white LED, which has a voltage across it of about 3 volts, if we use a 3 volt battery, we don't need a resistor. You do. You need, it can be quite a low value resistor, you know, 10 ohm or something, but you do want a resistor. Each of these pins can put out a maximum of 40 milliamps. Conversely, you can put 40 milliamps into it as well. We don't really worry about that bit. They recommend not drawing more than 20. And what you'll see is a lot of examples on the internet assume an LED needs 20 milliamps. So you'll get resistors. You'll see like a 5 volt circuit will have a 330 ohm resistor. I'll go into how to calculate the resistors in another video. It's not complicated, but it's a subject on its own. So, but what you'll see on a lot of sort of examples using the ESP32 and other 3.3 volt circuits, you will see people say, oh, use a little resistor, yeah, a 68 ohm resistor, a 100 ohm resistor, something of that nature. Yeah, I put a 330 in here because I'm going to put across here about 4 milliamps. Because where it says LEDs need 20, yeah, they'll take 20. They'll usually work at about 30 or 40. They get hot. 4 milliamps, most of them will light up, they'll be perfectly bright, and they won't get hot. That could also be a 470, which would put about 3 milliamps across it. It's one of the things to play with. A lot of the boards I've got in the cellar, where I built the board controllers, use 1K, so 1000 ohm resistors, and the LEDs still light up perfectly well. So it's worth checking. When you buy LEDs, they'll usually tell you some level of current rating. They will usually say it wants 20 milliamps. It doesn't. They don't want anything like it. So that is what the circuit's actually going to look like. However, that is how you would more normally show it. So here is a proper circuit schematic. Future videos I'm going to be using these because these are a lot easier to create than that, which as you can see is Microsoft Paint in all its glory. So yes, let's get this hooked in and we'll see what we're going to do. So the first thing is take the power off it. Very important, take the power off it. I'm then going to take my resistor. I'm just going to turn this a little because if I don't, I'm not going to be able to see what on earth I'm doing. And while I might be blind as a bat, that is, yes, anyway. So I have a pair of tweezers, because that will make this slightly easier. No, it won't. I thought it would. So we got pin 2, which is this one here. And what I'm going to do is try and get that. Is that the right one? Yes, that's in the right one. Now, these breadboards, as I said the other day, these 5 here are connected to each other. These 5 are. They don't connect across the middle. So I've put that's now connecting that pin to this side. Now need the LED. Now this has got, if I lay it down you can see it a bit better, 2 legs, and they are different lengths. It matters. The longer leg is the positive side. So I have 2 ways now of connecting this. I can connect it so the positive leg goes to this rail at the bottom. Like that. And that should... This is where we find out I really don't know what I'm doing and I should have practiced this a bit more. If I plug this in, that should now match the LED on the board. It'll either match it or be the exact opposite, one or the other. So it's the exact opposite. But it is lighting up. So what I'm going to do is remove it, power off again, turn it around, and now I'm going to connect it to the negative side. So we've got current will go from here through the resistor, through the LED to ground. And there we are. And that, ladies and gentlemen, is how you can use one of these things to turn an LED on and off. Now, fairly obviously, that is quite basic. However, the point of this video was to stay quite basic. All I really wanted to do was show how you set one of these things up so you can program it. We will, in the next video, look at doing slightly more to this with how we can make it talk to the host computer and how we can look at some inputs as well. So we can have little buttons and we can do things. But hopefully you can see from this that you could control a bunch of LEDs. The thing's got plenty of pins. There's ways to get around that. You'll normally find when you buy one of these boards, if it's got an onboard LED, it will flash when you power it up because that tends to be what's loaded. They're not always, but they tend to be. Obviously, LEDs come in multiple colours. Ooh, colour light signals. Yep, you could do colour light signals with this. And let's just do another little further experiment. I haven't planned this. This is what I'm going to try now because I think it might work quite nicely. You saw when I switched this thing on, I had the LED the other way round. Well, I've got another LED here. And what I'm going to do is just... I probably should have unplugged that then, but never mind. I'm going to plug that back in there. And I'm going to take this other one. And I'm going to plug it in the other way round. There. Oh look, we've got a 2-aspect colour light signal. Being driven by a single pin that you say what state you want it to be in. Do you want the light to be red? Do you want the light to be green? Now that could potentially prove quite useful. Obviously not just on a heartbeat signal like this. There's some other bits and pieces. But there we go. Now, I say that's fairly basic. I shall just move that more towards the centre for the other bits that will pop up on the screen shortly. I hope excuse me. I hope you found that informative. We will move on to some slightly more complicated bits, but this is the first stage of this is get this thing talking to the computer and working. I will also show this thing connected to a Linux system, and in the next video I will have found a way of getting those menus on screen to appear. Yeah, so that I can actually show you what we were doing. In the meantime, thank you very much for watching. The response to the first video in this series was phenomenal. I hope I'm going to be able to keep up the interest. If you like the video, there is a button for that. Sharing the video, telling your friends about it, telling people you don't like about it, telling people you think need a cure for insomnia about it. All of that's very welcome. Subscriptions to the channel don't cost anything, so they really help as well. And yeah, the little bell to notify. It's all good stuff. Anyway, that's quite enough waffling in this channel. I will catch you all in the next video. Thank you very much, and goodbye. Da-da, 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 da-da.